The Delta maths are for a grade on accuracy. Your homework is for a grade on completion. So if I put all the answers up there every single time, at least you're writing down the process of how to do something correctly and you're going to learn from it. Does that make sense? And I give you like really you have quite a bit of time. And the reason it's like this is because there's just so much content. And I'm sorry, but that's just kind of how it is. Okay. Go to your next, we're going to go to page. So page 7 and 8 is your homework. However, the answers are what? Posted. Are they posted right now? Yeah, they are. It's Friday. They're posted already. Okay, here we go. Say again. Yeah, isn't that what it says? Due September 20th with the rest of the packet? Does it say that? Okay, then why did you ask that? Okay, let's go to page 9. So this is your 2.2C, compound interest. Compound interest. So yesterday we learned that growth and decay, P equals 1 plus R to the power of T. Okay? So we're going to use this formula right here to answer these questions. So this is kind of our warm-up. If I have a 4% annual interest rate, the decimal is 0.04, and I'm going to add a 1 to it. It's growing, right? My interest is growing. So that means that, and I'm looking for 1 year's time. So in 1 year, my beginning value, 500, times 1.04 to the power of 1. Well, that's just 500 times 1.04, which is what? Any calculator bunnies out there? It's about $520. Well, we're going to use the same function and find out how much money we're going to have after 5 years. So that means I'm just going to use the same beginning value, same multiplier. I'm just changing my t to my exponent gets changed to a what? A 5. Okay, so 500 times 1.04 to the power of 5. How much money is that? Well, it's about $608, and I got 33 cents. Okay, Jane, you should probably pick your head up because I think you're just sleeping. I've totally lost you. This is the second time you're just nodded out. So now we're going to change t to 20 years. 500 times 1.04 to the power of 20. So how much money do you have in your account that grows at an annual interest rate of 4% after 20 years? 1,095.55. Good job, sir. Okay. Well, sometimes interest isn't accrued annually. Instead, it's compounded in increments. So sometimes it's compounded quarterly, sometimes it's compounded monthly. So the first thing that I want to talk to you about are the compounding periods. So if something is getting compounded monthly, how many times is that going to happen in 1 year? Say again. 12 times. So the number of compounding periods in would equal 12. If something is getting compounded quarterly, how many quarters are there in a year? 4. So n equals 4. If something is compounded semi-annually, every what? That's biannually. Semi-annually is in half. Semicircle half. So your number of compounding periods is 2. If something was compounded daily, oh my gosh, how many days are there in a year? So that would be n equals 365. If something was compounded biannually, that's what you were talking about, Josh. That means that your number of compounding periods would be 1/2, because it's how many times does it happen each year? It happens every 2 years. That's why it's 1/2. Okay. So we're going to use this formula for compound interest. P is still your principal or your initial value. R is still your rate that you write as a decimal. T is still your time. The only difference is we threw an N in there for the number of compounding periods. Okay. So here's our first example. What would happen to the $500 that you invested at 4% if it was compounded monthly for 1 year? So our compounding period monthly means that N is going to be 12. Our beginning value is still 500. Our rate, 4% as a decimal. And our time is going to vary. We're going to do it for 1 year, and then for 5 years, and then for 20 years. Okay? So let's see what happens after 1 year. We'll compare this to the one in the top. So 500 times 1 plus my rate, 0.04, divided by N, the number of compounding periods, which is 12. Do you see that? To the power of N times T. Well, 12 times 1 is just 12, but I'm going to write it that way anyway. 12 times 1. So how much money is that 500 going to be after 1 year? 520. And what'd you get? Point what? 0.37. So you've made 37 cents more compounding it monthly than you did in the one above it. Let's see what happens after 5 years. So same thing, 500, 1 plus 0.04 divided by 12, my number of compounding periods. But now my time is 5, so I'm going to take 12 times 5, which is actually 60. Yeah, that's what I got, 610, 50 cents. So now we're going to do this for 20 years. Okay, so 500 times the quantity of 1 plus, well, my rate, 0.04, divided by 12, number of compounding periods. But now I have to take my number of compounding periods, 12, times my time of 20. So that ends up being raised actually to the 240th power. What'd you get? That's what I got. So which one makes you more money? Compounding annually, like when you do annual interest, or when you compound it in a period, like monthly, quarterly, semi-annually? Which one is going to make you more money? Compound interest. So how do your answers compare? They're bigger. When we compound. That's why credit card companies and loans and all of those are calculated on a compounded interest instead of an annual interest. They want to make more money. Okay. All right. I've got these two posted. These two are posted. I'll do one of them. Do you want to do one or two? It doesn't matter. One. Okay. So 1,000, this is our P value, is invested at 3%. So 0.03. It's compounded quarterly. That means N equals what? 4. And my T value is 5. So let's see. Our equation, 1,000 times the quantity of 1 plus my rate, 0.03, divided by my number of compounding periods, which is 4. Close my parenthesis, all to the N times T power. Well, I'm going to write it out, 4 times 5, but you guys can just put it into your calculator as 20. So how much money are you going to get after 5 years at 3% compounded quarterly? Yeah. Do you see where we're getting that information? So for the bottom one, if we were compounding daily, what would your N equal? 365. Okay. So flip it over. Okay. So now let's consider this. This is an introduction into Euler. So you have $1 to invest. That's it. What is the maximum amount that your dollar could grow in the course of 1 year if it could earn 100% interest? Well, let's think about it. If it happens annually, that means that it's just happening once, 1 divided by 1. So that looks like this. I have $1. That's what I begin with. So it's 1 plus, well, my growth rate, 100% is what as a decimal? What is 100% as a decimal? The whole number 1. Yeah. Divided by number of compounding periods. It's only getting compounded once. Okay. To the power of 1, because it's only being compounded once. Well, let's see. What is 1 plus 1 over 1? 2. And what is 1 times 2? 2. So the most money that I could make if my money just was compounded once, like annually, just one time, and it grew 100%, the most I could make was $1. So I would end up with $2. Okay, but what if we compounded it quarterly? So let's see, I have $1. 1 plus, well, it's compounding at 100%, but quarterly is divided by 4. And I have 4 times 1 on the outside, right? Because it's getting compounded 4 times. And I'm just doing this for 1 year. We're just doing this for 1 year. So how much money do you have now? Well, 1.25 to the power of 4 is what? Anyone doing that? 1.25 to the 4th power? 2.441. Okay. So what do you think is going to happen if we compound it monthly? Well, I began with $1, and then my formula, 1 plus, well, 100% divided by monthly happens 12 times. So that's going to be 12 times, I'm only doing this for a year. So I can't remember what the decimal 1/12 is, but I don't know. 1 and 1/12 to the 12th power is what? 6-1. I got 6130. Did anybody else get that? Okay, Noah said yes, so we're going with it. Daily. Okay, so I started with $1. My formula 1 plus 100% is the whole number 1 divided by 365 to the 365 times 1 power. How much money do I have now?
I got 2.715.
I got 2.7145. Is that what you got? Okay. All right. Hourly. How many hours are in a year? We'll just take 365 times 24. What do you get? 3,760? Oh, 3,000. Oh, 8,000. I got you. Okay. So I have $1. That's what my beginning value is. And I'm putting into the formula 1 plus my percent, which is 100%, divided by the number of hours. I'm compounding it to the 8,760th power. How much money does it have now? So now our money is getting compounded every single hour. How much does it grow now? 2.7181. Okay. What about every minute? 524,000, you said? 20 and 600? Good job. Okay. So I started with $1 and then my formula 1 plus, 1% or 100% is the whole number 1. And I'm dividing this by 525,600 to the 525,600 power. So now I'm compounding my money every single minute. Every single minute. Just more interest, more interest, more interest. How much is it now? 2.718. Isn't it 829, 828, 827? Because I rounded mine up to 83. Is that okay? What about every second? Go ahead, I'm ready for you, Aiden. You didn't figure out how many seconds are in there? Oh, it's in scientific notation? 3-1. 5-3. It should be 3-1-5-3-6-0-0-0. Okay, so there are, let's see, 31,536,000 seconds in a year. Oh my gosh, I don't know if I can squeeze this in here. So 1 plus 1 divided by 31,536,000 to the 31,536,000th power. How much money is that? Because basically every second is like continuous, right? What'd you get now? Okay. So what is the most amount of money that $1 can be worth if you compound it constantly? Constantly, constantly, constantly. Yeah, $2.72. That's the most it can be worth. This is a very special number, and it's called E, and it came from Leonard Euler, a famous mathematician who lived 300 years ago. And he's responsible for the much of the math that we use. But this Euler number, or E, is used as a base, and we use it when something is being compounded continuously. We use E, the only time we use E is when something is being compounded continuously. Things that compound continuously are like cell reproduction, bacteria growth, things that just keep going, like aren't in control of like a human pushing a button, okay? So the formula that we use for continuous compounding is A equals capital P, which is your principal, times E, Euler's number, which is our growth rate, to the R times T power. Okay? So your homework for this is page 11 and 12. Hang on a second, I'm not done. Then you can read